Hello, my name is Shivakrishna Dasi. I am doing PhD under the guidance of Dr. Lalita Vadlamani from IIIT Hyderabad. Another contributor is Aditya M. Nair. I am going to present our work on maximally recoverable codes for various topologies. Locally recoverable codes are eraser codes which are used to minimize the repair degree. So the classification of erasers are as follows: single erasers and multiple erasers. Within multiple erasers, there are independent failures and correlated failures. Codes with R comma delta locality. Even in the presence of delta minus 1 erasers, a symbol can be recovered using R other symbols. Here is the example for codes with hierarchical locality. If there are more than delta failures in a local group, mid-level code with locality R1 can be used. Maximally recoverable codes are class of codes which can recover from all eraser patterns which are information theoretically recoverable given in the construction. Here there are 6 erasers and 5 equations and 5 unknowns which can be solved. In this case, there are 6 erasers, 4 equations and 5 unknowns which cannot be solved. Here Q3 is not useful. MRC with hierarchical locality. Pick K plus H1 symbols from the code such that it contains R1 symbols from each mid-level code. It contains at most R2 symbol from each local code. Those K plus H1 symbols should be formed K plus H1 comma KMDS code. Construction of MRC with hierarchical locality. So these are the local codes parities, and these are the global parities of the mid-level code. These are the global parities of the global code. The betas are picked from the base field FQ, and alphas are from the extension field of the FQ, and lambdas are the extension field of the FQ power M1. Pick alpha ij as delta plus 1 H2 y is independent over FQ, and lambda ijk delta plus 1 H2 plus 1 H1 y is independent over FQ M1. The sets alpha ij and lambdas picked as columns of parity check matrix of certain BCH codes. In order to deal with correlated failures, product topologies are defined. In this code words are in M by N array. Each row is belong to the row code. Each column is belong to the column code. The regular eraser pattern is defined as follows. So number of erasers in any grid is less than equal to UV minus U minus A into V minus P. It is called as a regularity condition, and this is the example for regular eraser pattern. For A equal to 1, regularity condition is necessary and sufficient, but for A greater than 1, it is necessary but not sufficient. So example of non-recoverable irregular eraser pattern is as follows. If you see, this is the maximal eraser pattern. The number of erasers in these two grids is 8, whereas the dimension of these two grids is 7. That's why it is not recoverable. A product code is said to be an MRPC which can recover all recoverable eraser patterns. Shortened code and puncture code of an MRPC is an MRPC. We can prove the following by using shortened code property. Suppose even E2 are recoverable eraser patterns in TMN A comma B, and these two are row-wise GZ, that is U1 intersection U2 equals to MT, and this can be recovered by in the TMN to A comma B. So G is the generator matrix for the MRPC, and this even is recoverable with the shortened code of G matrix with respect to U1. E2 is recoverable with the shortened code of generator matrix with respect to U2, that U2, and we have generated for such L erasers patterns, and that is union of such erasers are recoverable in TMN LA comma B topology.